So today's lesson is just talking about some quadratic relations. Now, we've changed the way we're going to do this course a little bit by actually doing the investigations first. Then what we'll do is at the end of the course, at the end of this unit, we're going to do a summative that ties in all our information. Now, let's just focus on what this is. So the first thing you got to do is make sure you download Desmos. And when you download Desmos, you just literally go to this site. So you either go to Desmos on your regular computer, or you can use it as use the browser site inside your phone or computer. Let's see. Let's go on desmos.com, and what you do is you end up with a screen like this, or it'll ask you to install Desmos on your computer. Now, what we're going to do is we're going to go and take a look at the graph y equals x squared. When we take a look at the graph y equals x squared, this is what we get. So we get a graph that looks like this, which literally looks like a U. And that's what our base graph is. Now, if we were looking at the graph, we would see that the graph, when we go and create, say, a table of values. So what you do is you go and change this x value and this y value. Notice the y value needs to be what it's going to end up turning into. So if it's y equals x squared, the x squared goes into the y column of our chart. And then we start by typing in our first number in our set. So in this case, I'm going to type in the number 3. And you'll notice that the -3 actually shows up on our graph as +9. And the reason why that is because what we have here is when we go and take our y value and we substitute x as -3, we have to put it in a bracket. So we get y is equal to -3 squared, which ends up being just -3 times -3. And if you use your calculator, you end up with just 9. Now, that's basically the gist of what all that's about. So once you've got your first number in your list of points, notice how my cursor is here. If I hit enter once, the computer needs to understand what your steps are going to be. So I'm going to put a -2. So now the computer understands that if I start at -3 for x, then my y is going to be -2. So now when I hit enter again, it's going to give me the next point in the sequence. And these are the base points that we use for our graph, from -3 to 3. And that allows us to make this nice curve. So now that we've done that, we're going to take a look at the properties of this curve. Okay? I'm just going to close this off. You can take a look at it later by reviewing the video. So now, just like I said, the basic graph y equals x squared looks like a U. And we already talked about what this is. It's just a parabola, we call it. Now, if I have the equation y equals 0.5 x squared, we're going to plug that into Desmos. And when we plug it into Desmos, we're going to use that and we're going to compare it. So if we go y is equal to 0.5 x squared, you'll notice that my new darker red graph is literally a little flatter or a little fatter compared to the original. So our new graph looks like this. Our original graph was the red one, and our new graph looks like this. We say that the graph is wider or fatter. Mathematically speaking, we say that the graph is compressed vertically. Now, when we say something is compressed, in mathematics we mean that we're dividing it by a number. In this case, think of 0.5 as a fraction. 0.5 as a fraction is 1/2. So essentially what we're doing is we're compressing something and dividing by a factor of 2. So what we've just done is we've taken all the y values that our original graph had, and all we've done is chop down their heights. That's all, by 2. So for our next graph, we're going to have y equals 3x squared. So let's take a look at that on Desmos. So we end up with y equals 3x to the power of 2. So you'll notice that my new graph ends up being a little skinnier. Okay? So instead of going over 1 and up 1, we're going to go over 1, and now we're going up exactly 3 points. So if I can get my mouse on there, you'll notice that that value there is approximately 3. Okay? Now, what that means is our graph starts like this and then ends up like this, the green graph. Now, what we say is our graph is just going to be skinny in this case, which is represented by the green graph, and our original y equals x squared graph is this. And we say that it is stretched vertically. So the opposite of compressed is stretched. And what we say is the y values of our equation are stretched or multiplied by 3. And we say that is stretched by a factor of 3. So now our next equation is y equals x squared plus 3. So let's take a look at that on Desmos. Now in Desmos, I just added what we call a slider. So this is x cubed plus 3, so let's change it to x squared. So on x squared plus 3, when the k value is 0, and now in this case we say that our k value is going to be plus 3. So let's see what happens when we have plus 3. So for plus 3, all it means is that our graph has shifted up and all the points stay the same. So now what we have is the following. We have a graph that looks like this with a new graph that's just shifted up. So this plus 3 that we have here has now literally just moved the graph up. So we end up with something like this. Our graph literally just shifts up. So all of the base points that we have just moved our graph up, and this is what our green graph is here. So now we have this next part. So in this part, it says we have x squared minus 5. So when we go to Desmos, if we go and move our k value down, when we subtract 5, literally our graph shifts down exactly 5 points from the original. So if we used our points at, say, 1, 1, our new point is going to be 1, negative 4 on our next graph. And then the same happens for all these. So in this case, we now have a graph that literally starts like this, then ends up shifted lower. We say that the graph shifts down or translates down. This is our new keyword. Translates down exactly 5 units. And so now let's take a look at our next graph. So our next graph is y equals x squared plus 4x plus 6. Now there is no way to graph this, but I can tell you right away that this is also a quadratic. And the reason why it's a quadratic is because the highest power here, the highest power or the degree of my equation, my relation, is 2. And the 2 refers to the exponent that is on the highest power of my equation. And now, when we go and plug this equation into our work, we end up with the... So when we plug this into our graphing utility, we have y equals 4x squared plus, y equals x squared plus 4x plus 6. Now, you'll notice that this c value that we have here, this c value, this last number, this number that is unique, is basically tied to the y-intercept. Because if you think about it, if I wanted to find the y-intercept, what we'd do is we'd let x equals 0. And we end up with something like this. Y is equal to 0 squared plus 4 times 0 plus 6. So 0 plus 0 plus 6. So therefore the y-intercept is equal to 6 in that case, which is what we expect on our graph here. So now, basically, if I can have an equation in this form, I can always tell what my y-intercept is. I just can't tell what my positions are unless I use a table of values, which looks like this if you're not sure. Now in Desmos, if you want to get a table of values so that you can graph this, what you do is you're going to insert a table. You're going to change this from x1 to x, and then you're going to change this y1 into the second half of the equation, y equals x squared. And then we're going to go plus 4x plus 6. And then we start by plotting all the points. So I'm going to start at, say, negative 5. So negative 5 is positive 11, and then we can use that to graph. And then we go negative 4, and now we can get all the base points and then use those to graph our sets, our new relation. And you'll notice that our graph has literally moved up 2 points and over to the left. So you literally would say this translates up 2 and right. Oh, left 2. Left 2. So let's go back to our work that we have. So as we discussed earlier, any quadratic has a degree power 2. So we're looking at the highest power that's in the relation. And we say that it's a quadratic because its degree is 2. Now, what we're going to do is once we graph that, which we saw back here, our new graph has moved up 2 and over 2. And this is where our vertex is. Now, our vertex is literally the point of the graph that is either the lowest or the highest point. So in this case, that bottom part would be our vertex. And our vertex is going to be negative 2, 2. So now for the next concept, when we have y equals negative x squared. So when we have y equals x squared, literally what happens is we have a reflection in the x-axis in this case. So we actually have a mirror line on the x-axis. So anytime we have a negative number that's sitting in front of the x squared term, it literally means that our graph is opening down. If it's positive, our graph is opening up. And so what we say, it's been reflected or flipped vertically in the x-axis and stretched by a factor of 2. So now when we look at our next equation, y equals negative 2x squared, let's see what that looks like on our... Just like before, when we had y equals x squared, we have negative x squared. So essentially what we've done is we've flipped it, right? And then when we have negative 2x, that means there's some form of stretch that's happening. And if you take a look at this graph, it really means that the graph has been stretched by a factor of 2. The negative sign goes and tells us that we flip the graph. And the 2 tells us we have a stretch factor of 2. So anytime you have a stretch, the number that's sitting in front of the x squared term is bigger than 1. That's all you need to know. And now, let's continue. So this one here is the -2 means it's flipped first. That's what the negative means. And then the 2 that's sitting in front also means it has a stretch factor of 2. And it's stretched vertically. Now, let's take a look at this equation. Y is equal to -5x squared. Based on all the concepts that we have here, the negative really means that it's flipped first. Then all the y values are stretched by a factor of 5. Now, our next problem I'm going to give you is y is equal to -0.5x squared plus 6. So if we wanted to describe all the stuff that happens, the negatives means that it's opening down or flipped. And then we want to say that the 0.5 is between 0 and 1, so this is going to be compressed. But the factor that we compress by is, well, 0.5 is the same as 1/2, so our stretch factor, our compress factor is 2/1, which really is 2. Okay, and our vertical translation, there's going to be a vertical translation here, and our vertical translation is up 6 units. And we're good to go. So now we'll move on to the next set of problems, which is just determining what these things are. We're talking about a thing called first differences and second differences. On this chart here, make sure that you also have this for our y equals x squared. This one here for y equals x. And then let's do that again.